Okay, welcome students. Welcome to physics class. I'm still your physics teacher, Mr. Moses. I hope that you went through the last topics that we did. In the last class, we looked at types of thermometer, where we visited the gas thermometer, and we said that the gas thermometer works with the principle of the increase in pressure of gas when temperature is increased at constant volume, such that when the temperature rises, the pressure of the gas rises and then flows through the tube, and as it is flowing, it applies pressure on the thread of the tube, which is pushed upwards in the calibrated area. We also visited resistance thermometer, where we said the resistance thermometer works with increase in resistance of a metallic conductor and increase in temperature. Today we'll be looking at the liquid in glass thermometer. Now this thermometer works with a liquid inside a glass tube, a narrow glass tube. When there is an increase in temperature, liquid tends to expand, and then when there is a decrease, it contrasts. So basically, the liquid in glass thermometer works with the principle of the expansion or increase in volume of a liquid when temperature rises, and then the decrease in volume of a liquid when the temperature reduces. So like you saw in the picture, like your clinical thermometer, when there is increase in temperature, the liquid in the tube rises up. That means its volume increases. And then when there is a decrease in temperature, it decreases. That's how the liquid in glass thermometer works. The liquid mostly used are liquid mercury and alcohol, but best of them all is liquid mercury. As you can see, we said the working principle of the liquid in glass thermometer. The liquid in glass thermometer works with the increase in volume of a liquid with proportional increase in temperature. And then for the effectiveness of the liquid in glass thermometer, we said 1, it has to have a bulb made of thin glass. The reason why it is made of thin glass is because it is used to measure temperature. If the glass is thick, it will not be able to pick the temperature of the surrounding effectively. So the glass has to be thin so that the liquid can pick the temperature of the surrounding effectively. 2, we said it has to have a narrow capillary tube with uniform bore. The reason why the tube has to be narrow is because we are measuring temperature, and so there might just be little increase in temperature. So the volume of the liquid has to increase. The increase in volume has to show, no matter how little the increase in temperature is. And when the tube is narrow, you can achieve that. And then the liquid used has to have high expansivity. When there is increase in temperature, it has to expand. We also say that the liquid in glass thermometer must have 1, high expansivity, as I just said. When there is increase in temperature, it has to have the ability to expand well, so that for every movement that it makes in the thermometer, it will be seen or noticed. 2, we said it should expand or contrast uniformly with temperature. It should expand when there is increase in temperature, it should expand. When there is decrease in temperature, it should contrast. 3, we said it should have a high boiling and low melting point. Very high boiling point, because there are temperatures that are beyond the 100 degrees Celsius that we would want to measure, and then there are temperatures that are lower than 0 degrees Celsius. So it has to have a very, very low melting point so that it can cover for all range of temperatures, and then it should be easily seen in glass. It should not be a colorless liquid like water, so that as it is rising and going down we can see it. Hence we say that water cannot be used as a thermometric substance, because one, it freezes at 0 degrees Celsius and boils at 100 degrees Celsius. We just made mention of the fact that the boiling point has to be high. If it goes above 100, water can no longer increase in temperature. If it goes below 0 degrees Celsius, water freezes, so it cannot be used. Two, it does not expand uniformly with temperature. According to Abnormall's expansion of water, between 0 and 4 degrees, water contrasts instead of expand. Then when it gets to 4 degrees, it begins to expand again, so it cannot be used because it doesn't have uniform expansion with temperature. Number 3, it has high boiling point and low melting point, where it does not have. Number 4, it wets glass. The liquid used in a liquid in glass thermometer should not wet glass. That means that if it is going up and down, we should see it clearly. There should be no droplets that is staying on the glass, so that it can be clear. And then it is colorless. Water is colorless, and we need to see the liquid. Then we go to the pyrometer. This is a popular equipment that we use in school. When you enter the gate, they use it to face your forehead and then get your temperature. It measures temperature by absorbing radiation from the surface of the object that it is pointed at. When an object is heated or when something is hot, it gives out radiation. So this pyrometer picks the radiation from the object and measures temperature according to the amount of radiation produced by the object. That's what the pyrometer does. So whenever it is pointed at your forehead or at your face, what it is doing is that it is picking the radiation of heat. The radiation of heat from your forehead picks the radiation of heat from the object. So the amount of radiation now uses it to tell the temperature of the body in question. That's how the pyrometer works. And then we go to heat capacity. This is the amount of heat required to raise the temperature of the body by 1 Kelvin. Its unit is joule per Kelvin. Heat capacity is simply saying if I apply heat on a particular object, the temperature that the amount of heat that I need to apply to make the whole object, not some part of it, the whole object to gain heat by 1 Kelvin. That amount of heat is called heat capacity. Now when you start heating an object, some parts get heated first before other parts, but heat capacity deals with heating the whole object, raising the temperature of the whole object by 1 Kelvin. And here we have the formula for heat capacity: Q over change in T, where Q is the quantity of heat applied and change in T refers to change in temperature, hence the unit joule per Kelvin or joule per degree Celsius. So when we measure heat capacity, we're talking about the heat applied to raise the temperature of a whole body, not some part, by 1 Kelvin. So if the temperature was 10 degrees Celsius, to raise it to 11 degrees Celsius, the heat required is heat capacity. And then we go to specific heat capacity. Specific heat capacity is the quantity of heat required to raise the temperature of a unit mass of the substance by 1 degree Celsius or 1 Kelvin. What do we mean by unit mass? We said that matter is made up of molecules, yes? If the object weighs 10 kg and I apply heat to the object For 1 kg of that object to gain heat, the amount of heat required for 1 kg of that object to gain heat, not the whole object. When we describe heat capacity, we said the whole object. In this case, we are talking about a unit mass. For 1 kg of that object to gain heat, the heat required is called specific heat capacity. And then its formula is shown above. So we have change in E over m, that's change in theta, where change in E is quantity of heat or thermal energy, m is the mass in question, change in theta is the change in temperature, and we have C to be specific heat capacity. So heat capacity deals with increase in temperature of the whole body by 1 Kelvin, and specific heat capacity deals with increase in temperature of a unit mass of the whole body. So 1 kg mass of the whole body is what specific heat capacity is. Here's an example. It says the mass of the sample is 4.7 grams. Upon absorbing 57.2 joules of heat, the temperature of the sample rises from 25 degrees Celsius to 57 degrees Celsius. Find the specific heat capacity of the sample. We know that specific heat capacity is Q, which is heat, quantity of heat, sometimes represented as E over mass times change in temperature. Hence, we have the replacement of the formulas to get the answer. So basically, that is the formula for specific heat capacity. I hope you understand this. Please go through the videos, go through the leading questions and the quiz. We'll explain more in class. Thank you for watching.